It's like a really, really nice quality of life upgrade in the testing world over the last years.
Your wallet, your ledger, or whatever you use, this can now become a smart contract. And this is a very important change.
Welcome back to PEEPanEIP, where we dive into the latest developments in the Ethereum ecosystem. This is episode 137. I'm your host Pooja Ranjan, and today we are excited to discuss the DevNet for Pectra upgrade. Prague-Electra, also known as Pectra Network Upgrade, is now on developers' testnet, also known as DevNets. EIPs have been shortlisted and client teams are implementing them. But how is the implementation going on? How safe are these EIPs for the Ethereum mainnet? To answer these questions, I am joined by two fantastic guests who have been at the forefront of testing, Parithosh and Mario Vega from PEEPanEIP and Ethereum testing. Welcome to the show, Pari and Mario.
Hey, thank you for having us.
Thank you.
Before we dive deep into the EIPs and the DevNet jungle, could you briefly introduce yourself and share what you have found the most exciting in Ethereum space right now?
So I can introduce myself first. Hi, I'm Parithosh. I'm a part of the PEEPanEIP team. We normally help take care of DevNets as well as specifically on CL testing with, of course, some EL testing sprinkled along the way. I'm really excited with the changes to account abstraction / how the user experience for Ethereum is going to change. I think as a user of Ethereum, that's also probably going to be a very direct, visible change. And I'm looking forward to how that evolves.
Yeah. So my name is Mario Vega. I'm from the Ethereum Foundation testing team. The primary focus of the team is to do specification testing. So basically, we test the forks, the changes, and that every client implements the spec with rigorous testing, spec testing, functional testing. And we also do a little bit of interop testing. So basically, both sides of the layer. And yeah, it's been pretty interesting. I've been here like 3 years almost. And yeah, it's been a great ride. Yeah, I think the most important thing, or at least what I feel most excited about, is it's also 7702, to be honest. Yeah, it's the same thing. It's amazing. It's like I wanted to use it in mainnet already. But yeah, a lot of testing to be had first. And I will explain a little bit more in the slides.
Interesting. Thank you so much for sharing. Yeah, we look forward to hear more about 7702 and account abstraction and how you people are dealing with these proposals on the Pectra Devnet or Devnet in general. So without further ado, let's peep in.
Awesome. So, hi, we're going to be talking about Pectra testing today, trying to give you guys a holistic overview of what EIPs are in Pectra so far, as well as how we're trying to tackle the different testing needs that these EIPs have. Just a bit of a disclaimer with the ACD process, sometimes which EIPs are included, etc., do change over the scope. We might be adding more EIPs, we might be replacing EIPs, etc. So take it as this is how Pectra looks absolutely like today, and this is how we're approaching testing today. A sort of, I guess, second disclaimer, because Pectra is so big, there's of course certain optimizations we had to do. I guess the easiest way of thinking about it is in a lot of past forks, we have like at least 2 testing teams at the EF. We have a bunch of testing teams on each client team. We have a security team. So all of us looked at the same set of EIPs. Also because the EIPs touched about similar sets of the stack. For example, Denkun was largely networking / mempool changes. And with the merge, it was largely interop and figuring out how the transition happens. With Pectra, it's a very ambitious upgrade. So we're touching many layers of the stack, each of them with its own intricacies and requirement of expertise in. So we've tried to split them as best we thought. So each of us are also going to be taking over different topics of the parts that we're looking into. So yeah, hopefully all of this makes sense. And I will hand it over to Mario to start off with his part, and then I will see you guys again later.
Yeah, so the first part of Pectra, or the way that we can split it, is having the execution part of the upgrade. So it's composed by two upgrades. One happens on the EL and another one happens on the CL. They implement different changes, but basically they have to be in sync. So the fork happens and both of these upgrades happen at the same time. And it's very important they happen at the same time because they depend on each other. But for testing purposes, what we usually do is we separate this into two, and then we also do a third iteration, which makes testing like the interrupt operations between them. So there's basically three phases of this. I'm going to start with the first phase, which is the execution spec test, how we do the execution layer testing, and then what upgrades or changes are included in this layer. So in my opinion, this has to be the most impactful fork for the EVM yet. Just by the numbers of how many EIPs are we trying to fit into this is basically just 7 EIPs that impact in some way or another. Some impact a little bit less, some impact a little bit more, but basically 7 EIPs impacting the EVM plus 8 separate EOF EIPs. It's not separate, but it's basically we can put them in two buckets. They are all going into the same upgrade. Just to get some numbers of how things are changing, this fork introduces 9 new precompiles. This is only for the BLS EIP. It's a single EIP that introduces these 9 new precompiles. I will explain a bit more what they do in a following slide. The other thing is that we introduce 3 new system contracts. So a system contract is basically something in the EVM that has a special property. And when users execute them, things happen that are special to the blockchain. In this case, these new system contracts, they basically just send information over to the consensus layer clients. And this is very important because they affect what happens on the consensus layer. So the validators and all that stuff. It's very important that we test this both in the EVM layer only and the interpretation layer too. We have a new, what is called a requests bus. Basically, it's a way of, so very, very hand in hand with the previous bullet point is basically, we have a new way of communicating stuff from the execution into the consensus layer. This is very important because information has to happen synchronously. So whenever this action happens in the EVM, the consensus layer has to be aware of it. So this is why this is like a requests mechanism that we send from EVM to CL to the consensus layer. We have a new transaction type. So far we have like transaction type 0, 1, 2, 3, and now we will have the transaction type 4. This is a very important new feature that users will be directly impacted. So basically, this is the start of a counter abstraction, base layer account abstraction. So we already have smart contract accounts, and these are very useful for different purposes, but this will allow the external own accounts, is what it's called, basically your wallet, your ledger, or whatever you use. This can now become the smart contract. And this is a very important change. And we have the first ever introduced new smart contract container type, which is the EOF version 1. This is a very big change. This by itself introduces so many changes that it contains twice as many tests as some previous forks, just to give you an idea of how massive this change is. This will introduce maybe not that much visible changes for the user. Well, in terms of gas costs, it will impact the users positively, but most importantly, it will allow the developers to deploy these new smart contract container types, which include more information about what happens inside of the smart contract and what are the characteristics of the smart contract. This will be contained into the account. The code will now have more information, and now it will be easier to analyze what happens and how and what things can happen inside of the code of the account. And yeah, we have separate from EOF, we have 0 new opcodes, I think. And for EOF only, this will introduce 19 new opcodes. So basically, they re-implement existing functionality, but now this is in the EOF world. So it contains some contain more restrictions, some contains new functionality, which I think is very useful. But we'll talk a little bit about that in a following slide. So yeah, the first EVM, basically EVM only, this doesn't concern the consensus layer at all, is well, a little bit, but indirectly, is the 2537, which is the BLS precompiles. This basically is just a new precompile. If you guys don't know what the precompile is, it's basically just existing code or existing logic or existing algorithms that reside in the client's code. They are not smart contracts. They are basically optimized pieces of code that the client put for the users to use. One of the things that we couldn't do before this EIP is that we didn't have the ability to in any way verify the signature type that happens on the consensus layer. This is going to change with this precompile. Basically, it's going to introduce the ability to the EVM to validate signatures, to do some other cryptographic operations with the same cryptographic primitive that the consensus layer uses. This is important. It doesn't affect directly the consensus layer, as I said, but it does give the users the opportunity to do things with either the signatures of the validators and fancier stuff that I guess this functionality will become more useful as more smart contracts use it. One of the things while we're testing this is basically the testing itself is pretty easy on the EVM side. What is not is the cryptography. So for this, what we use some pre-existing vectors that the authors of the EIP designed that are designed to test all the properties of these VLAs, cryptographic tools. Yeah, and yeah, that's basically it for that EIP. Next one is the 2935. This is one of the first system contracts that we're going to talk about. Basically, so far in the EVM, when you try to know the history of the blockchain, you are capped at 256 blocks in the past. So before that, there's no probable way to know if a block was in the history of the blockchain inside of the EVM. Of course, if you have a client outside of it, it's observable, but inside of it, you are capped at the last 256 blocks. What this thing does is basically it expands the history by putting it in the state. The state is basically the memory of the smart contracts. And this is a very big memory. So we are able to put 8,196 blocks in the past. But this is not only to allow smart contracts to access this information, but another very important feature of this is that the light clients, which normally depend on a lot of information, they will no longer need to try to get those 256 blocks in the past. Basically, this information will already be in the state, which you can generate a proof. So it's easier for the light clients to validate a block. You will require less information. You can instantly, if you have the proof, you can instantly verify that a block is correct. And this will become even more apparent once we switch into Berkel, because Berkel proofs are very small. Right now, the proof that the execution of a block is correct they are very big. Now, but once we hit Berkel, this specific EIP is going to prove itself to be very, very important. A small amount of tests. One caveat of these tests is that they are huge. Basically, the biggest test that we have produced, the way that we produce tests is we fill blocks each one by one. And because of the nature of blockchains, this has to be serial. So we cannot parallelize this process. And normally, when we filled the EVM tests in the past, it was less than 10 minutes. Now it has bumped up to an hour or more, just because of this EIP. But these tests are a necessity because otherwise you don't have the verification of this functionality. And so it's pretty important that we fill them. The next EIP is, oh yes. So yeah, we have this set of 4 EIPs. These ones are the main interactions with the consensus layer. So we have 6110, 7002, 7251, 7685. Basically, the last one is just like a meta EIP for the previous tree. And this thing, what it does is basically it will provide actionable events from the EVM into the consensus layer. The only event that happens now in the EVM that has repercussions in the consensus layer are the deposits. And right now, the way that the information is passed onto the consensus layer is like a little bit janky. I mean, it's not janky, it's like out of sync, asynchronous, because the EVM, you make a deposit to a validator in the consensus layer. Basically, it raises an event, and then the consensus layer has to go all the way back and then read these logs and then parse them one by one. And then they have to come up with a mechanism to vote for which block contains the valid deposits. So it's like not synchronous. It's like it's convoluted. It works, but we can do better. And this is what happens with EIP 6110. Basically, now the deposits, whatever happens in the deposit contract is now a system contract. Nothing will change about this, about what it contains, but it will now have direct repercussion of what goes into the block header. So now when you make a deposit into the consensus layer for your validator, for your 32-bit, because you want to validate. What will happen is that the header will have more information, which the consensus layer will directly read, and then it will process it immediately. So it will be synchronous, faster, and more seamless for the validators. It's a very nice addition. At the moment, I think right now, if you deposit, it will take up to 16 hours just for the consensus layer to realize that your deposit went in. From after this EIP, it will be instant. This is a similar thing with the other two EIPs. The 7002 is basically a similar thing. It's a new contract that also will have repercussions in the events that are transferred into the consensus layer, but this is for the withdrawals. So basically now, the withdrawal credentials that a validator has set in the consensus layer, you can use this because this is an EVM account. Basically, you can send transactions from it. You can send a transaction to this contract from that address, and then it will trigger a voluntary withdrawal of this validator, which means that, for example, in the past, before this EIP, if you wanted to withdraw your validator, one of the issues is that you have to have the key that signs the attestation, signs the blocks, that signs basically everything that happens in the consensus layer. With this EIP, this can be now triggered from the execution layer with the withdrawal credentials. So it gives you more freedom to do things safely, because if you, for example, lose your key of the attestations and the block signing that happens on the consensus layer, you basically need to wait until you are kicked out of the validator queue at the moment. And now it doesn't matter, because now you can simply, if something happens to the key, this key in the consensus layer, you can go into the execution layer, send a transaction, and then you will trigger a withdrawal for you. Similar thing with 7251. This is what is called the consolidations. Now you can basically merge two validators. And this is part of another very big change, which I think Parithosh will talk a little bit more about in the coming slides, is basically you can mix two validators if you have the keys for those. And you can do this from the execution layer, which is pretty cool. So far for testing, I think the most important part on the EVM is to verify that the interactions, once any account interacts with these three contracts, this is reflected in what is passed into the consensus layer. And also another important validation is that the client cannot accept a block when the requests do not match the interactions with the smart contracts. So this part is relatively simple to test in the EVM world. But when we pass into the interop world, which is the execution layer and consensus layer, that's when things get complicated, because now you're affecting the other chain, the consensus layer. Yeah, basically the EVM part of testing is relatively easy. The interesting part comes in the interop. And for that, we use Kurtosis, Hive, Assertor, and the Devnet. And I think Parithosh will talk a little bit more in the upcoming part. And yeah, this is the one that I was talking about in the introduction. This is the authorizations list. In simple terms, basically, you can convert your existing wallet account into a smart contract. This is pretty exciting because you can now, as you can see now, if you want to, for example, make a swap or make basically almost any operation, you have to first approve, and then you have to say the operation. But now, since you can convert your account into a smart contract, this will no longer be necessary. It allows basically the user to gain the power of multiple transactions in the same transaction, among many other things. But the part that I'm most excited about is like allowing the existing keys to become a smart contract. This is pretty cool. The testing involves, mainly we have a new transaction type, which is already pretty hard to test. The gas cost is something that is very, very tricky when you are introducing a new way of executing code into the EVM. This is very thoroughly tested. And yeah, a new type of account basically, because now the wallets, they're basically known as the externally owned account because they have a private key. You can sign stuff with them, and you can send transactions. They now can also contain code. So this new execution context of running things in the EVM, this laid out a very big ground to test. So we have been very careful of trying to test every single context. All the opcodes that we have in this new context is pretty tricky. Also, this is the new feature that is going to be tested in the Devnet tree, which I think also Parithosh will talk a little bit more. There's also important for this is that there's a lot of cross EIP testing in this case, because when we test something for the EVM, we are not only testing this new IP in an isolated fashion. We also have to go back and look what previous tests does this EIP affect and how we can update them to be able to test this in conjunction with new features. One of the things that we have gained in this latest fork, and to some extent in the previous fork also, is the ability that we have now the PyTest framework, which allows us to parameterize and do a lot of crazy stuff and do rapid iterations of generation of tests with many combinations as we can think. And this is very, very important because now we have one of the new combinations is that this new account abstraction type transaction, we have to combine it with previous things. And this PyTest East, as it's called, it allows us to do that very quickly. Yeah, and also apart from only EVM testing, this is just talking about EVM testing, but there's also a lot of testing that has to happen afterwards, because while we are pretty sure that the EVM changes do not break something, then comes the implementations from the wallets, the implementations from the smart contracts, and that's another whole thing that has to come slowly and will advance after the fork, during the fork development, and also even after the fork. Just to give you an idea, this produces around 1,000 tests, but I think there are many cases that are missing, so it will easily go over 1,500 or something. It's still work in progress. Yeah, and one pretty exciting thing is that if you want to help us test in the Devnet tree, which is the upcoming Devnet, you can do so. This is basically a script that I prepared in the last 2 hours. It allows to generate this new type of transaction. So if you want to try account abstraction, I recommend for you to visit first the branch. This is the branch that contains all of the tests, but not only contains tests, it also contains the logic to generate this new type for transaction. So if you want to try it out, and you have some time and want to just mess with this new transaction type, please go into the script. You can take a look. Basically, what it will do is just generate an account for you, and will give you the private key, which is just a random number, and it will generate for you a type for transaction. Then you can, when Devnet 3 is launched, you can just send it to a node, and you can see what happens. It's pretty exciting. I hope some people try it. All right. And yeah, the biggest EVM change, in my opinion, is the UF. This is the first time that a smart contract code container has been introduced into the EVM. Before this, there was no container. Basically, you have the code and you have the instructions that it executes, and that's it. There are some downsides to this because you don't have information or meta information about what the code does, what opcodes does it execute, the jumping in the inside of the code. That's something that you cannot analyze very easily right now. Basically, this brings a lot of order into the chaos that is now allowed in the code. It allows you to basically containerize and put the code into a safe, well-known place. And this gives you a lot of guarantees. One of them is that you cannot do, for example, stack overflows. You cannot do stack underflows. You cannot jump anywhere. You can jump only into restricted areas. So that makes the code very, very deterministic. And this is pretty cool because it allows code developers to do a better analysis of the code they are writing, and also be sure that something that is already in the chain only behaves in the expected way. This, I think, the main thing that comes out of this that will impact the users positively will be that there will be less gas consumption, so a little bit cheaper transactions, I think. But yeah, it will come after a time when, for example, all the compilers, all the smart contract writers, they have to update to this new type of writing their code. There's also a lot of testing-wise, it's been very intensive. This is, I think, one of the EIPs that has yielded the most amount of EVM tests. As you can see, we have right now, as the time of writing, we have 12,000 tests, which is basically 2 forks. So it's a lot. And there's still a lot of pending things to do with regards to testing, which is basically that this thing touches a lot of existing parts. So we have to go back and analyze existing tests to see where this thing fits and where we can expand the existing testing to also accommodate this new type container. Again, the PyTest framework, the execution spec test has grown a lot. It really helps us out that we can parameterize and then really quickly come up with multitude of test vectors from the single idea. You can parameterize and just create a bunch of test cases. And this also allows us to retroactively update tests to automatically test these new container types. So that's one of the things that we have been working on a lot in the past year to enhance the way that we test, not only the tests. Yeah, one last comment is that maybe this is probably the biggest revamp to the smart contracts since Ethereum's inception. So that's something to note. But yeah, on to Pari.
Awesome. So yeah, we're not done with the upgrades scheduled for Pectra yet, even though we've probably already counted multiple forks worth of tests. So the EVM team tends to focus a bit more on the EIPs that I'm going to be talking about. The main understanding or the reasoning is that CL-focused EIPs tend to require a different style of testing. You can't always have a pre-state, post-state as you would with the EVM. You tend to need these messier network conditions where things are happening, sometimes seemingly at random, to trigger seemingly at random bugs. Unfortunately, that also means they're a bit harder to trace down each time, but I feel like we're getting better with what tools we use, etc. So CL specific Prague upgrades, we're going to be changing significantly how the CL staking layer works, as well as how peering works in the CL layer. So there's MaxEB first on a high level, and then I'll go a bit more into a deep dive the same way Mario did. So MaxEB will change what the max effective balance of a validator can be. So today, it doesn't matter if you make a deposit with 64 ETH, 96,000 ETH, whatever, you will still be one validator on the network, and that one validator has a voting of 32 ETH. So that's the maximum effective balance, and this will be changing. And I'll talk about how in a bit. And PeerDAS will change a lot about how the P2P layer works on the CL side. So it changes what pieces of information you need to download from your peers. It changes what pieces of information you need to store. And this fundamentally changes what the assumption is for what is a valid block, what is an invalid block. And it changes a lot on that level. But the benefits are also huge. This makes it significantly easier for solo stakers to run nodes at home and continue to keep up with the network, even though we may increase scaling and blob limits, etc. So it's a very required change, in my opinion. EIP-7594, I don't know who it was, Kurtosis or someone else, who mentioned that it's like a tiny line item, but it changes how attestations look. And attestations are everywhere in the CL world. So it's a really sensitive change that we just kind of forget about. But yeah, it changes how attestations look. It takes something out of the existing attestations. And I'm going to repeat a bit about the request bus, so the execution to the consensus stuff that Mario was talking about with deposits, with withdrawals, and all of these will also heavily affect the CL world because validators need to be deposited and exited. So we need to make sure that the interop is working between the two layers, but also between clients on both layers. So trying to follow a similar format to Mario, I will introduce the tools themselves later, but try and keep the name in your head. Assertor is what we would use mostly for EIP-7251. So this is max effective balance. So this is what changes and allows you to have more than 32 ETH in one validator. So you could, for example, if you have 2000 ETH, deposit all 2000 ETH into one validator, and this would be having a voting weight of 2000 ETH. So earlier you would have had to have, I don't know, 30 plus validators of 32 ETH each, and you would have to run these somewhere, typically on one machine. So, but the network would still treat it as 30 plus individual validators. So one big change that MaxEB does is, why don't we just consolidate all of these? They're all belonging to the same owner. They're all running on the same machine likely. Why not just represent one validator with a higher voting weight? My opinion, it's a really logical change. It'll change a lot as to how many messages get gossiped. So the P2P layer on the CL side is very noisy, and this would significantly reduce that. There's, of course, bounds we want to make sure we keep, but still, this will reduce the amount of information that needs to be sent across the network. And one way of looking at it is working on scaling, at least. It doesn't always mean just adding things. Sometimes removing things also allows you to have the headroom to then add things somewhere else. So I think that's one of the easiest way to look at MaxEB. And I'm sure there will be further implications with the issuance guys and the staking roadmap people and the different types of rainbow staking, etc. But MaxEB is kind of a logical change that has its hands in a lot of places, I guess. Unfortunately, though, this has a lot of edge cases. We have to treat this EIP with the understanding that we're also changing how deposits work and how exits work. So we're changing what a validator is, how you become a validator, and how you stop being a validator at the same time. So there's a lot of edge cases here, and we have to keep in mind what these edge cases are, especially in terms of how the network looks when these edge cases are. Right. So what are these new states that the validator can be? Can you only do a consolidation if both validators are healthy? What happens if one of the validators but it had already submitted a consolidation to become a part of another validator, right? So there's a lot of edge cases. So the tool we use is Assertor. I'll speak a bit more about it, but you can find the Assertor test we have for MaxEB there. We're still so far at the happy path test, so I can't give you a nice impressive number like Mario. We're still trying to knock out all the issues. I think one of the difference is in the type of CL testing, just writing the test won't really work for us. We kind of need to make sure that the tests work themselves. For that, we need clients that work. And the last time we wrote happy tests, we already found some issues in consolidations. So we kind of had to stop there, wait for clients to have the fixes so that we can write more tests to figure out what we can push it to. The next one that is extremely impactful is PeerDAS. And the tools we're going to be using largely are Hermes and Xatu. I won't be talking a lot about either of these tools, but Hermes is a tool built by ProbeLab. It's an amazing research team if someone wants to look them up. And Xatu is a data collection and analysis platform that we built at the EVM team. Xatu is a tool we heavily used for the DNAP upgrade to try and understand how blobs propagate around the network, when they are seen where, what the impact is going to be when we know how many blobs is too much for the network, etc. So for example, right now you can have target of 3 blobs, max 6. We had to come up with that number somehow. It was one of the tools that helped us come up with that number. So we're going to be using this along with Hermes, which sits on the peer-to-peer layer, accepts messages from all sorts of peers, and then it adds some annotations and tags that we like and uploads it to a server. And in that server, we can then do a lot of analysis to try and see what's being received, from who is it being received, how's the network behaving, when we do something, what happens, and so on. So this really helps us get the peer-to-peer layer view of the network. So PeerDAS itself is going to change how blobs are passed and which nodes custody which blobs. And by custody, it introduces a concept of supernodes as well as regular full nodes. So you can imagine supernodes as nodes with a lot of validators. So the moment you have above X number of validators, the chances are you're doing so many duties that you have to keep up with everything happening in the network all the time. There's just no way around it. You have a lot of validators. But say I have one validator somewhere in the middle of nowhere, right? I don't have to keep up with everything in the network. So PeerDAS allows you to get away with storing lesser while still fully participating in the network. So this allows us to reduce the burden on smaller stakers as well as nodes that have 0 validators, while increasing the burden a bit on nodes that have a lot of validators, because a lot of validators also imply that it's probably a more professional system, it probably has more resources and so on. This, like I mentioned, allows a reduction in bandwidth for some nodes. So instead of downloading everything from the network, you can download a percentage of what you need and reconstruct the rest locally. And it lays the groundwork for increasing the number of blobs we have. So instead of 3.6, tomorrow we can say, hey, PeerDAS, made the network a lot less noisy, increased our throughput, so we could go to 612 or whatever number that we decide is making sense. However, this, as you can already imagine from my explanation, introduces a new concept of a node, like the supernode concept. And this is very sensitive because it touches a lot with fork choice, because now you have different conditions under which something is valid, as well as peer-to-peer changes. There's just a lot of changes in, I would say, one of the harder parts of the stack. Like anything touching peer-to-peer is a lot more adversarial in nature because anyone can connect you, anyone can do anything. There's no checks and balances there. So it tends to be really hard to test. And some of these edge cases are also really linked to network conditions, which are hard to simulate. So there might just be some cable between I don't know, India and Dubai that got cut, that led to some validator having a higher latency that had some other effect on the network because suddenly a percentage of your traffic has to reroute somewhere else. How do you simulate that? That's extremely hard. And that's what we try to work on with different tools. We're actively building the stack to make this better. So the security team has someone named Tyler who's also working on updating AttackNet, which is a tool we use for the DNAP changes that allows us to like simulate network faults, that allows us to simulate latency increases and stuff like that. So we haven't gotten that far yet. So PeerDAS is still actively in the research implementation stage, which is why we don't have extremely strong tests. We're still more on let's get basic stuff working. Let's see how to visualize the network, and then we figure out how to break stuff afterwards. And so you might have seen some tools that I haven't mentioned yet. And I think one of the approaches we've chosen is to rely heavily on Kurtosis, which is also a tool that I might have introduced about a year-ish ago. Kurtosis is a local testing tool similar to Hive or execution spec test that Mario was talking about, except this spins up the entire client for you in a full-fledged DevNet. So all the pieces of the DevNet that's required would exist here, including the MEV stack. So you would have relays, etc., if you require it. The benefit of doing this locally is that in under a minute, you can test if your changes worked, and you can test it if it worked for not just your client, but also someone else's client. And one of the problems we're trying to solve is as a Geth dev, you're really good at running Geth. But if I ask you to today run Bezu, you might not be that good at it. You might not have the scripts for it. You might just not care how to run Bezu. Abstracts the whole thing away from you. We give you simple to use YAML that I will probably showcase after this. That just allows you to specify what you need, and then the tool does the magic. You don't have to worry about it. Since it's custom and local, we can also mess with a lot of parameters. So you can have 3-second slot times instead of 12. You can have your forks happening at epoch 1, epoch 2. You can use mainnet spec or minimal spec. So it allows us to add this layer of I just want to know if this works, and I want to know in under a minute because I don't know, that's how long my coffee takes to make. Can I do this or not? And the next benefit is allows us to share stable configs. So if you look at the ETH R&D interop or PeerDAS testing chat, in the pinned messages, you'll already find Kurtosis configs. So the benefit is if me as a Lighthouse dev have tested that Lighthouse works, and I got together with Teku and we both know ours works, you can pin a configuration, and then the Nimbus guys can download that and then add the Nimbus client and see if that works. And then we iteratively can add this list until we have all the clients. And since they are all doing this on their local machines, you don't have to coordinate it with anyone. You don't have to do anything. This really reduces dev churn. You don't have to ping someone from the DevOps team to deploy anything anymore. We can sleep in peace, and you can still be sure that what you're doing is working. This is just like a really, really quick example of how the network looks. Yeah, that's really how fast it takes to spin up a DevNet. It's, yeah, by the time you even look at what's happening, it's kind of up. We spent a lot of time making that work nicely over the last year. Another tool you might have seen is Assertor. So Assertor is a test assertion tool we've built, similar to Hive, but specifically focused for DevNets. So there's no concept of like, this is the starting point and this is the ending point, but rather this is the ending point. Is the network doing what I expect it to do at this stage, right? I have a brief example after this that might help a bit more, but this is built with the idea that networks are messy. Nodes might have different views. How do we check what views they have? How do we ensure that the network is still going to be okay? The benefit is Assertor, you can configure it via its library, you can configure it via the API, you can configure it via the GUI. So we built it once and you can use it in many different places. A simple example is Assertor runs against the Holsky testnet and the Sepolia testnet, for example. It does a validator deposit. It waits till the validator gets online. It waits till the validator proposes a block. Then it exits the validator, and then it does this again. This process might take days, but the benefit is we always know that we haven't broken deposits on public testnet or public devnet. The whole concept of Assertor kind of started last year where the Nimbus client has a specific bug, I think, with deposits that we were just kind of surprised, hey, we can test for this regression because it just felt like, oh, deposit should work. So this is one of the tools that helps us make sure that those basic regressions don't get deployed on mainnet. It's really useful for long-term tests. So like Mario was saying, some of their tests take like an hour to do. I think an hour is like the starting point for anything we start looking at tests. We're basically looking at days worth of tests here. So it's also built with that mindset. It's built with this set up and forget. And it's integrated into Kurtosis directly. So you can do it locally, you can throw it in the CI, you can do a lot of really cool things, and you can reference all the tests based on GitHub URLs or like public URLs. So you can update the tests as often as you want, and all of your test executions gets updated along with it. It also allows us to do some validations. So now when we run a DevNet, we also run a few validations via Assertor so that we know that basic EIPs are working. Happy path should work all the time. You can find the QR code for Assertor over there. And this is just like a really quick Kurtosis config for how an Assertor test looks. So this will check if the network is stable or not. It'll check if every client has proposed a block. Then it'll wait until slot number 34. And then it'll submit 300 BLS changes. And then it'll make sure that those 300 BLS changes have been included as expected on the network. As you can imagine, this can get as complicated as you like. And the output sort of looks like this. You can see a nice green when something happens. And as you can see, the massive deposit example has a timeout of 600 hours because you really don't know how long the massive deposit takes based on the deposit queue and who else is ahead of you, etc., and how many deposits you're submitting, to be honest. So yeah, this sort of reinforces the mindset that this is like a long-term life cycle test for a DevNet. And I think this is a nice view of how different things pipe together. So you have the execution spec test that Mario was talking about. You have consensus spec tests that Xiaowei and a lot of other researchers and client team devs tend to write. All of these can be run locally by every dev. So execution spec test that Mario runs, not only will he be running it, but also the Nethermind team will run it and the Bezu team will run it and make sure that stuff is working. Once they feel like they're mostly there, they'll usually give us a branch or an image or something to use. We'll tend to configure it in a Hive so that we can go through a bunch of tests in Hive that takes hours. We'll also run it through in Kurtosis as well as Assertor. So we do our own local tests to make sure that the network is working as we expect. And once we're kind of happy that, hey, whatever could be tested locally worked, now, why don't we have like a shared environment where we can do wilder things, where some random person from the public can deploy a 7702 transaction that we might not have even imagined in our tests, right? That's when we get to the DevNet stage, and that's basically where we are today. Just as a quick side note, the DevNets that you see don't yet have all the EIPs listed. So we are prominently missing 7702 and EOF. So the next version of the DevNet will have 7702, and the version of the DevNet afterwards will have EOF. And PeerDAS in itself has its own testing cycle. So there's PeerDAS DevNets that don't do anything else. And we mainly made this split so that teams can concentrate on different issues at different places instead of throwing 100 EIPs into one DevNet and nothing working and no one knowing why. Yeah, so once we've passed the DevNet stage, we will probably have more feature complete DevNets. So you might remember the Kiln testnet or the Kintsugi testnet we used to have during the merge. So these will be a bit more public with more fanfare. We might have, I don't know, people can easily interact with it. You can find documentation, clients might make releases with it and so on. Because there's so many EIPs, we want to get these in the hands of as many people as possible for as long as possible, so that actually sure that all the edge cases we can't think of are being tested. And this will be especially useful for tooling developers. 7702, for example, will be a huge change for wallet developers. And they need some place to test stuff. They need some place to look at and say, okay, that's what I'm going to try my alpha software against. Or with EOF, like someone needs to test their deployments and make sure that the deployments work as expected. So this is the stage where we're pretty much ready that this is what's going on to testnets, but we're not there yet and we want like public feedback. That's when we'll have this. And once we're done with this stage, we'll have shadow forks, and then we'll do the public testnets. So the Holsky and the Sepolia will go through the fork. And once all of that has been successful, that's when you'll have the mainnet fork happen and scheduled. So this is mostly the life cycle of how the next, I guess, few months are going to look from the testing perspective. And yeah, what next? Send us names. We don't yet have a name for whatever the testnet is going to be called. There's no theme, there's nothing else. Send us name suggestions, and please try out Mario's 7702 example. Let us know what you find, break stuff. It's still early, so we're really happy if people break stuff. And thank you. Follow us on Twitter, and we're around for questions.
Thank you both for this great talk. It was enlightening how much testing goes into each upgrade, and especially this one because this is a combination of 2, 3 upgrades altogether. I love the idea of bucketing these proposals and taking them together to test. Like I remember in Mario's presentation, there was like, okay, these set of this would be the EVM proposals, then this would be for account and this for bus and related. That was brilliant. I think that is not only helpful in testing, but it is also helpful in understanding for general people, like what all changes people can expect with this particular upgrade. So that's great. And just for our listeners, want to mention that we have recorded multiple episodes for Pectra Upgrade. We are also trying to bring a detailed overview of all these proposals. So please check out our playlist, Pectra on ETH Cat Herders YouTube. That will provide you more information about each one of these proposals. And thank you both for already answering most of the questions that I had on my list. I think my list is pretty light. So my first question is, like, I know you mentioned about different devnets being active and it is being tested separately. If you have to give a number or a count or just a perspective to the community, how many active devnets / testnets are there as on date?
Not that many, actually. So we have one devnet for Pectra. We have one devnet for PeerDAS. And then we have Holsky and Sepolia as public testnets. So that's 4 altogether. So it's actually not too bad, I would say. We try to keep the chaos a bit limited. Also, mainly because we've shifted to this paradigm of local testing. So earlier, when, for example, the SSE guys, there's a whole sphere of EIPs under that's still like, potentially being considered with changes to how SSE looks between the EL and CL. They have their own devnets, but they're doing it with Kurtosis locally. So it doesn't have to involve anyone. It really reduces the load on developers to trying to keep up. It's like, here's a config. If you want to play with this stuff, download the config and run it on your machine. It really simplifies people's lives.
Great to know. And it was mentioned that DevNet 3 is planned to be deployed. Do we see more versions of DevNet? If so, how many more versions are we expecting?
It's really hard to give an upper limit. So DevNet 3 will add 7702. DevNet 4 will add EOF. And we have DevNet 2 on PeerDAS side that is supposed to come with a lot of fixes and changes that they have. And then DevNet 3 on the PeerDAS side will rebase on top of Pectra. So right now it's based off of Deneb, and then in the future it will be based on Pectra. And once we have done that, we have DevNet 4, Pectra DevNet 4, and we have PeerDAS DevNet 3. Technically, the DevNet afterwards should be a combination of the two, if we think that's the way to go. But we're kind of like 2 to 3 DevNets away from what I would define as Pectra as explained by us right now in one place. So I wouldn't say that's the last DevNet. There's probably at least like 5 more or something after that. It's going to be a long cycle.
How many were there in Cancun? I think there were 12, right? Or
yeah, I think we did 12 DevNets in Cancun, and would say a
new
similar
record.
number for, yeah, I wouldn't be surprised. I mean, it's so many EIPs. Yeah,
Could happen.
it has to happen.
And it is already making a new record and including all the number of EIPs that has been for any upgrade.
I think a lot of people have mentioned like, oh, this is as big as the merge. I actually think this is significantly bigger than the merge. I felt like even in the merge, all of us could kind of have an overview of everything that is happening. With this fork, I think there's a significant chunk, especially the EVM side for me, which is like a black box. I have a high level overview of what's going on, but I will probably never get as deep in the weeds as either Dano or Mario or whoever is testing that side of things.
Same thing. Yeah, it's way too big, and thankfully we can split efforts. For now, it's
Thankfully, it's
much more manageable.
splittable. And also, huge shout out to Barnabas. So the whole PeerDAS section that I mentioned was what Barnabas is taking over. So kind of the CL world is also split in two again. So I take care of more MaxEB, probably the deposit stuff, the passing between the two layers and so on. Barnabas is focusing a lot on PeerDAS.
I think we're not even talking
otherwise
about.
He would be. Yeah.
We're not even talking about Berkel, for example. Right now, some
yeah.
of the thing of the testing team is focused on Berkel, and I guess some of the DevOps teams are also focused on Berkel. So there's not only this thing that we're testing also in the future. It's crazy.
It's a lot. I feel like every time the testing team comes up with a smart optimization, the client devs add a new EIP, and then the optimization gains are just lost. Like a year ago, if you had asked me, I was like, yeah, we're gonna coast. Like we've automated so many things, we can like easily do 3-4 cycles of DevNets. And all the devs heard was, I hear you can do 3-4 cycles of DevNet, so we're gonna use it with many EIPs now.
Did you just say that we have more bandwidth?
Yeah, exactly.
It's not just testing of EIPs, but also testing of testers.
Yeah, definitely.
Very well. So we are talking about PeerDAS, Proposal 7594. PeerDAS basically is a networking EIP. And historically, for any upgrade, we have never included networking EIP for an upgrade. Only core EIPs are tested on DevNets. Do you think we could have kept PeerDAS separate and deployed async in each client? Or do you see value add by keeping it together with the rest of the core EIPs for Pectra upgrade?
So the main reasoning was we did actually consider doing it as a sort of staggered upgrade where Pectra would happen today, PeerDAS would happen like tomorrow, for example. The issue is that, yes, it is largely a networking change, but it also has fork choice implications. And anything with fork choice has a huge benefit of doing with coordination. So that's, I think, one of the biggest reasons for doing it along with Pectra. And the other reasoning is that, like a lot of client teams structured code in such a way that you can't just arbitrarily start a feature. Some client teams you can, in some you can't. So it's essentially in their code as if another fork is happening, which does make sense. It's sensitive enough that another fork is happening. So it's easier to do it with Pectra in that sense. I think from a risk mitigation perspective, I get what you're saying. It's easier to do it staggered later, but yeah, I think from a developer side, it's a bit more difficult that way.
Also for the node operators, it's usually they like having to update just once and then not trying to like, okay, first the Spectra, then PeerDAS, and so on and so forth. So yeah, it's better for them also.
Exactly.
Very interesting. Yes, it is always good to like keep it separate. I mean, I feel like it is better to keep it separate, but when there is relation in between two proposals and we cannot make a change to another one unless we make the change to the first one, it's better to club them together.
Yeah.
All right. My next question is about the risk and challenges. Now we are testing close to 20 proposals. Do you think of any specific challenge on including all these? Like, I know there are some CL level proposals, there are some EL level proposals, and there are certain proposals which are affecting both layers. So what specific challenge do you think of?
Yeah, so for me, the biggest challenge is cross-functional testing. So thankfully, we have the tools now to make this much easier for us, at least in the terms of trying to bundle a lot of tests and then just writing tests once and then just trying to create like this, what we call this the parameterization. So you run the test, you write the test once and then you create automatically the same test for other functionality. So that's what kept us from writing a lot of code, a lot of test code. It's just easier for us. But still, it's something that you have to keep in the back of your head. So, okay, when I'm writing tests for 7702, am I breaking this thing, all the thing? And it's important to really have a very big view of the EVM, at least for the EVM test, that if you're touching something, what else are you breaking? So that's like one of the most complicated challenges, in my opinion. Also, you're not only breaking stuff in the EVM, you can also break stuff in the CL. So that's another level of complications. And thankfully, we have managed to come up with a lot of strategies to do this more manageable. And I feel pretty confident about the testing that we do everywhere at the moment. Yeah.
Yeah, definitely the same. Cross tests between EIPs are insane. I think the example I try to always use is, imagine you have a EOA account that has done an authorization to a smart contract, but that smart contract is an EOF smart contract that wants to send a execution layer triggered exit that then triggers an exit, but that exit is a consolidated validator, and that consolidator validator has been slashed. Now you've changed like 6 different EIPs, which we never had to do before. And you have to not only look at the edge case of one EIP, but also like, how does a slashed EIP state affect a 702 authorization? I mean, we know how it should affect it. The question is if it will affect in a certain way. And testing that is really hard. And you can sprinkle in some network forking or split scenarios, and then you get into really dodgy territory as to what's actually supposed to happen when the network reorgs eventually and so on. But I will mimic what Mario said. We're significantly better than we've ever been in terms of testing tools. I have this document I keep pulling up. I think Mario's probably tired of even listening to that document at this point, but it's just like EIPs with the test scenarios that I can imagine. And one section I had there was, do we need new tools? And I think with every fork in the past, we needed new tools. With the merge, we needed new tools. With withdrawals, we needed new tools. With Denkun, we definitely needed new tools. Like Mario built the Blobber last year, and we were building Xatu to get like data visualization. For the first time, we didn't have to build any new tool. Like we had all the different pieces required. We just had to smartly integrate them. And of course, there will be stuff we can improve, but the fundamental tools we needed existed, which I think is a big change from previous years. Like we're starting to hit our stride a bit. And like there's one like alpha project that Mario's been really kicking through, which is that Assertor can then eventually use the execution spec test outputs so that like they write the EOF tests and we're able to use them on devnets. We've never been able to do that in the past. Like if it was a Denkun test, Mario's team had to write tests, we had to write our tests, and we would run them separately. So now we're also trying to like figure out how we can optimally reuse stuff between the teams. So I mean, none of this is here today, and I don't want to promise a future that doesn't exist, but I think we're getting to a stage where it's like really, it's getting synergistic. And I can't imagine that there's many forks that the devs can imagine that we don't have tools for. I hope they don't take it as a challenge, but yeah.
Tooling certainly helps. And you sharing a bit more about what toolings are being used for each of the testing, network upgrade testing. I think it is interesting and helpful for people or community contributor who wants to come and contribute. They would learn what kind of tooling you are using, and maybe you will get more helping hands.
For sure. And we're also trying to like keep the tooling so standardized that I don't know if you're an L2 or whoever else that you can contribute directly and L1 benefits, but also that L2 teams would benefit from these tooling changes, hopefully.
Pretty interesting. Well, my next question is something which is related to testing team itself. Like for an upgrade, we are testing proposals, but how would we say that this testing is enough? This is sufficient. How would we evaluate the success of Pectra Devnet testing?
Yeah, I think it really depends a lot on how many eyes have the test on top of that. So one person can write seemingly enough tests. For example, I tend to write for one EIP, but another member of the testing comes and says, okay, no, this is not enough. We have this gap. Or even when the testing team is sure that, okay, this is enough, there always comes the time when we pass the test onto the client and say, oh, hey, I wrote this incorrectly in the client and now no test broke. So that's the moment then you know that, okay, there's a missing gap. And then you go back into the missing gaps and then you say, okay, this is similar to this other thing that we could do. And then each iteration, the test become a little bit better. So I think this is a group effort in all of the sense. There's no single one person that can come up with the entire set of tests. After many iterations, after many eyes on the test, and many executions from all the clients, I think you can be in a safe spot that you can say, okay, this hasn't break anything new, and all the clients have consumed. You have all the feedback from the clients. I think you're in a safe spot, at least from our perspective. Yeah.
I think my easy marker is once you launch a DevNet, have a look at the interop chat and see how many messages there are. Ideally, as we increase the DevNet number, the number of messages after a DevNet launch reduces. And the moment it gets to DevNet was launched, nothing is found. That's when we feel like, okay, everyone's kind of done their job. At some point, it starts to feel routine. And I think my personal marker is when it feels routine with any leadership.
Less conversation, people getting comfortable, and it's getting perfect.
Yeah.
Good way to summarize that. Well, you have already shared about the next steps, like we are hoping to get this DevNet phase done, then feature complete testnet, then we will get into shadow forking as well before we get into the public testnet. So that's pretty good timeline. How long do you think would it take? I know this is the most difficult question to answer, but just trying to get an estimate here. How long do you think would it take to get Pectra on the mainnet?
I think it really depends, in my opinion, from ACD. So I think you can get a good measurement of how things are stabilizing. If you attend ACD and then you check how much discussion is still happening, the less discussion is happening, the closer you are. Right now, I think there's a lot of discussion still. So I would say months still, definitely.
I think we're still too
estimates.
actively talking about like adding more EIPs, which I want to try and actively discourage, but it's still an active conversation at ACD. Like one notable missing example is that we aren't increasing the blob count. And that doesn't really make sense. It's going to we want to increase the blob count. But then comes in the question, how do we increase the blob count? And then there's a EIP by Alex Stokes, which is the CL tells the EL how many blobs it needs to have. In principle, great idea, but it changes how certain parts of sync work, and that's going to be its own testing cycle. And it feels like if we're shipping PeerDAS, we kind of have to ship that, and then we have to ship a blob increase on top of that. So there's like at least 2 more EIPs that come in there. That just makes sense to ship. But yeah, it's kind of indicative of the problem we have, that one thing makes sense to ship, and then naturally it makes sense to ship the next thing, And I think first we need to get to this stable state of we can't think of anything else to ship. And only then can we start talking about like when the fork is going to happen. But I also agree it's like a span of months. I would not even remotely say weeks is possible.
I think this particular upgrade is kind of answer to many people who have been accusing of Ethereum getting slow on upgrades, like including less number of EIPs. So even if it is taking time, it is including as many as possible EIPs in one upgrade. Kudos to the team.
Yeah, I think if we pull this off, it'll be a massive change to Ethereum.
And we're not gonna rush things. Definitely, that's number one priority.
Exactly. It's going to be on mainnet only once everyone is happy that everything is tested, all cases are taken care of, and we're not going to break anything. Otherwise, I think there's not even a question of time versus security is never a thing. It's always going to be security.
That's quite comforting. Thank you so much for that. Well, it's about time to wrap up. Is there anything else either of you would like to share about Pectra Devnet, or any shout outs or any message for our listeners?
I think one thing is not many people know about execution specs or execution spec tests, at least. Maybe Mario wants to give a brief shout out to that.
Yeah, absolutely. So yeah, it's the main repository that the testing team works on. Just go to GitHub Ethereum/execution spec test, and you will find basically every single test that the EVM has to offer for you. You can take a look and dive in if you know Python. Even if you don't know Python, I think Python is pretty much self-explanatory. Just take a deep dive in there. We are always looking for helping hands, and if you are interested in some great challenges about writing tests, this is a place I think you should pay a visit. Yep.
Yeah, it's like a really, really nice quality of life upgrade in the testing world over the last year. So, I mean, huge hats off to the team, because that wasn't an easy thing to pull off.
Well, thank you. Thank you both so much for joining us today. This is Pectra's special episode of PEEPanEIP, and we loved hearing insights on the DevNets. This upgrade is possibly the biggest upgrade to the date, and it's fantastic to hear more about testing from experts like you. So thanks for joining us here today.
Thank you so much for having us.
Thank you so much for having us. Yeah, likewise.
For our listeners, thanks for tuning in. Be sure to subscribe and follow us for more in-depth exploration of Ethereum protocol. Check the description for links to the helpful resources, and we would love to hear your thoughts on this episode or any other proposal that you would want us to cover in future. Please let us know in comment below. Until next time, keep peeping those EIPs. Cheers.